work today on the shortcut for dividing a polynomial by a binomial. It only works if you have a polynomial and a binomial. The divisor has to be a binomial, or we can't do this method. Also, the coefficient of this binomial has to be 1. I will show you a trick to make it 1 if it's not 1. Once we do this first example, but we need to get this one down first. I did it very, very quickly at the end of last period, but we want to slow this down so that you can write yourself some notes so that you can understand what's happening. Okay, so the first thing you need to do is you need to just take whatever number is here in the binomial. You'll have an x or variable minus a number. Whatever number is subtracted is a number that goes in this little box right here. But you might say, well, wait a minute, Sister Doughty, what if it's not a minus? What if it's a plus? Make it into a minus. Make it a minus negative. So you might have a negative number in this little box. Okay, so let's put down step 1 here is that for the binomial, binomial part is in the form x minus a. Okay, a goes in the upper left box. It's much easier to do than it is to explain. Okay, so that's step 1. The next thing you do is you take a look at the coefficients in the polynomial. The polynomial has to be in descending order. In other words, you have to do the exponents have to be going down in order. So 3, 2, 1, no variable at all here. So you're going to take the coefficients of each one of these terms and line them across the top next to the number in the box. So the coefficient of this first term, Sabrina, is what?
I don't know, I'm really lost.
Okay, the coefficient is the number that's times the variable part. Okay, not the exponent, the number that's multiplied by the, so it's 6. Okay, so Sabrina, what would be the coefficient here? 19. Negative 19, good. So you do have to look for those signs in front. Charles, what about the coefficient here?
1.
1. It's hiding, it's a 1. And then this one, there's no variable, but you just take the number, that's its own coefficient. Okay, so your step 2 is going to be to put all the coefficients along the top. Like I say, it's much easier to do than explain. So I'm trying to get enough into your notes so when you look back you say, where did those numbers come from? And you have something to go by. Along the top. Okay? Watching to make sure there's anybody still writing. Okay, so then what we need to do is we're going to then draw a line as if we're doing a math problem. Well, that's because you are. But it's a strange looking math problem. you're going to just put a line underneath with the space right along here. So we're just going to leave a space, and we're going to put a line here, enough room for one row of numbers to go right here. Okay? Now, so you should have a list of numbers here. You have a number in the little box. First step that you're going to do, so it's your step 3, is you bring the first number straight down. Okay, so we're going to bring this 6 straight down. Bring the first number down. Okay, once you get good at this, it's a very, very fast process. All right? Then you're going to multiply the number in the box times the number you brought down. Okay, so you're going to multiply the box number times the number brought down. Okay, so in other words, we take 3 times 6, which gives you 18, and that number goes right here. Okay, so you bring that one up and you put it underneath the next number. Okay. Making sure everybody's got that written. Okay, I'm running out of space, so I have to keep on putting more things up here. All right, after that, you're going to add these two numbers. You're going to add the column. Okay, so I'm going to actually change colors. Add the column. So we add this and we get how much? Negative 1. Okay. Negative 19 plus 18 gives you negative 1. Okay. Notice this number came down. Okay, so in your notes, what you can do is then maybe make an arrow that goes back to 4. Because you're just going to keep on repeating between step 4 and 5. You're going to multiply the box number times the number that came down. Okay? Bring that up, add the columns. And you're going to keep doing that until you come to the last number and you're done. So on this next one, you get 3 times negative 1, and that gives you
Negative 3.
Negative 3.
And negative 2.
Add the columns. You add the columns, that gives you negative 2. Then you do 3 times negative 2, which is negative 6. And then this gives you a 0. Okay, now, that last number, okay, the last number is the remainder. The last number is the remainder. Remainder. The last number is the remainder. Okay, Okay, so this one right here, we'll put in another little box so that you can see it. It's set apart. It's not really part of, it's not part of the coefficients of the answers, but that last number is the remainder. Okay? When you get to the end of the problem, this last number is the remainder. So there's a remainder of 0. So in this case, there is no remainder. Sometimes we'll have a number there. If you get a number there, that will be part of our remainder, and I'll show you what happens with that. Preston.
How did someone even begin to think of this?
Well, after they had done a lot doing long division, and I know you were absent for the long division part, but when you watch that, after you do it, you kind of start to see a pattern emerge. And so I'm sure that the person who first thought of that was like, wait a minute. I'm always just doing, and this is just what happens, and they probably, developed it that way. Yes.
Is 0 always going to be the remainder?
No. 0 will not always be the remainder. As a matter of fact, I want to do one that is not going to be a remainder of 0 next. Okay, so let's go on with this. It is really not a good time to go to the bathroom, no. If we can wait, you have to wait. You absolutely have to, because we're not done the problem yet. So far, we don't even have an answer yet. But we have numbers that are going to be put into the answer. Those of you that were here yesterday, I did it super fast just to show you. But what we can do here is we take a look at these. These are the coefficients of the answer polynomial. Okay, what step were we up to? 7?
Yes.
Step 7. Okay, you need to use the numbers as coefficients for your answer. Okay, and it's easier to go from right to left than left to right. This one over here that's right next to the box is always going to be brought down just as is. Okay, as a -2. This one, if you think of it as place values, this is the x to the first coefficient. So this is really -1 x to the first. This is really the x to the second. Okay, this one is really the x to the second coefficient. Now, those of you that were not here yesterday, it was your assignment to watch that. So if you didn't watch that, some of this may not be making sense because you don't know what type of answer to expect. But you need to watch it. It's really, really important. Here is my answer. When you divide this polynomial by this binomial, you get this. So in other words, if I were to take this divisor and I multiplied it times this, you would get this number.
Could you just make a fraction bar and put it underneath this?
If you made the fraction bar and put it underneath, there's nothing that you can cancel. You would have to do the long division method that we went over yesterday, which takes a lot more time than the synthetic. Yesterday we went over the process, the long way of doing this, where you go through and you do long division like you used to divide out long numbers to figure this out. This is a shortcut. Okay, so you're dividing this polynomial by this. If you have a binomial, you cannot just go through and start canceling things. It doesn't work. Okay, like if you're thinking, oh, just make a long fraction bar, you cancel out the x. Well, what happens when you get to the 6? You can't do that. You can't break down something that's added or subtracted and just start canceling. Okay, you're actually dividing the whole binomial into this whole thing. This is a shortcut that makes the thing we did yesterday with the long division just easier. Okay, so you need to go through. These are the coefficients of your answer. So we need to keep that in mind. Okay, before we do one without a coefficient, I want to show you one with, still with a coefficient of 1 that gives us a remainder that is not 1. So let's get a new one. Yep, we're going to get a new one, and we're going to take, let's see, let's take 3x squared minus 4x plus 1. And we're going to divide that, divide that by x plus 7. Okay, so we're dividing this by x plus 7. We're going to use synthetic division for it. Now remember I said the first thing you do is you put a number in a box, right? Now actually it can't be 7, it's got to be -7. Remember those of
always
you,
make it like.
yeah, always change it so that it's a subtraction problem. I know you're used to going backwards and making minus negative into a plus, but you have to think about it this way so you know that -7 goes in the box. Then you go by coefficients. First coefficient is 3, then -4, then 1. Okay, there are our coefficients. They're all lined up. This one isn't quite as long of a problem. What do we do first?
Bring the 3 down.
Bring the 3 down. So we bring the 3 down, that gives us 3. Then -21 because you did what, Preston?
I multiplied the box number by the
Good. Multiply the box number times that number.
Really impressive.
So we get -21. Then you
Bring down 4.
add,
Add
and that gives us
-25.
-25. And when we multiply this, it gets to be kind of yucky. 175? Sure?
That's the 400.
175. And our number that comes down here is 176. That's this number. There's our remainder.
That's never.
Our remainder is 176. Now, these numbers here are the ones that are going to be the coefficients. So this one, this 25, just gets to be brought down by itself.
Okay.
Okay?
Yeah.
What does this one turn into?
And that's 1.
9.
3x. 3x.
Okay.
Nice.
These numbers are going to come down. They will be the coefficients. Now, we have a problem here. We have a remainder. Whenever you do division, in long division, if you remember, when you had a remainder, you always did remainder over divisor.
Oh.
What's the divisor here?
X plus 7.
X plus 7. So we have a very strange thing. We didn't get a polynomial answer this time. We have a polynomial plus a remainder answer. Okay, now, back from your old days of doing long division, that remainder over divisor thing, it's just like when you were dividing out and you'd have a mixed number, you'd have whatever was left over put over what it was being divided by, and that would be your leftover fraction. It's the same thing here, but it's in polynomial form. Okay? So this one is what happens when you don't get a 0 here. But once again, you have to have a coefficient of 1 here, or the whole thing doesn't work. Okay?
So you got it. Wait, hold on. Can you explain that? Hold on.
Yeah, whatever number's here
Okay.
has to go over the divisor.
Okay.
Okay, and that's your leftover piece.
All right.
Okay. Let's move on. I want to show you what happens if for some reason you don't have a 1 here. I think maybe one of them shows up or 2 in your homework, but I want you to see
2x.
if there's no 1 here and you have to do another type of division problem. Now this one's a tricky one, so follow right along.
I have a question.
Yes.
Instead of having like, could you just have like x there and then you just do the other substitute? Would that be possible?
Okay, hold on a second. I don't know what you mean by understood 0.
Like here, instead of 7, if you just had nothing, could you do 0 there instead?
A 0 here?
Yeah, would that be instead, or what would happen? Or would it just be
We can do it X.
If it was just x here.
Yeah,
What more?
If it was just x here, if it wasn't a binomial, you wouldn't do synthetic division. Because this only works for binomials. You will do, yesterday we learned a method for that where you split it down into several problems.
Ew.
And whether or not it's your question, it's valuable, so you need to pay attention to the answers. So we're doing this only with binomials, dividing by binomials. All right, so let's get another one. So we can see what to do. Okay, we're going to take 4x to the 4th minus 5x squared. This is going to have another issue too, so this is a great problem.
Yay.
Wait, a great?
Plus 2x
Good problem.
plus 4
No, it's actually not.
Isn't that
You have a good
divided by
Oh,
2x minus 1.
are you speaking?
Is that no solution?
No, it's not no solution. We can divide this out. I need everybody's 100% attention here because this is a tricky one.
I'll try to remember.
Yeah, because
No.
I see.
There's no point in my wasting my time getting halfway through this if everybody's not really paying attention. It's tricky. You need to be able to catch every little bit of it before we can do this problem. Okay? Now this one has a couple of issues. First of all, there's no 1 coefficient here. Second of all, notice we go from 4 and skip to 2. So we have to make sure that we figure out how to handle both of those issues. Now, in order to get this coefficient to be 1, we need to divide the whole thing by 2.
Now we have a half.
But if I divide this one by 2, I have to also divide this one by 2. Okay.
I really don't. But
Now, listen to me. One like this, you might say, well, I'd rather do long division on this. If so, then fine. I'm just showing you how the synthetic division works with this. You need to be writing it down. It's too difficult for you to go away with nothing.
No,
You need to.
I love it.
You need to be writing it down. Okay, you don't have your notebook out. There's no way you. Okay, well,
I forget my glasses.
make sure that it's there for you. So here we have these. We're going to divide each one of these pieces by 2. Okay, so this one becomes
2x
2x to the 4th.
Oh, that's not different.
This one becomes negative 5 halves. We're going to leave it as a fraction.
Okay.
X squared. This one, 2 divided by 2 is 1. 1x. This one, 2 divided by 4. And 4 divided by 2 is 2. And then that's all going to be divided by x
Minus 1.
minus 1/2. Okay? Like I say, this one does get a little tricky, so you got to pay attention. What goes in the little box?
1/2 or
half.
negative 1/2.
Regular 1/2.
Yeah.
Because it's always, you want to put it in minus form. It's already in minus form here. So we got 1/2. Now we have to go through the coefficients. Now watch what happens. 2x to the 4th.
2.
We don't have a third, but we have to give it a placeholder,
A 0.
a 0. Because there is no x to the third. There are 0 x to the thirds. We can't ignore it though. It needs a placeholder. Then x squared is
Negative 5.
negative 5/2. X gets a 1, and then you have a 2. So watch out for the placeholder.
Oh, okay, that's important.
Okay, that is important. And I'll tell you right now, your test, your quiz is going to show one that's got a placeholder. So you need to make sure you put in placeholders. If there are missing pieces, x to the third is missing, it needs to get a 0. So let's do this. We need to bring down the 2. 1/2 times 2 is 1. 0 plus 1 is 1. That's nice. 1/2 times 1 is
1/2.
1/2. Negative 5/2 plus 1/2 is
Negative 2.
negative 2.
Yeah.
So this is turning out not to be so bad. 1/2
Only slightly off.
times negative 2 is
-1.
negative 1, and this is 0.
And 0.
1/2 times 0 is
0.
0.
And 2.
And we do have a remainder.
Look at that.
Okay, so the remainder is going to be a little bit weird to look at. We'll have to do a little converting with that. But here, we have 0 comes down as itself. We're going to clean up our answer at the end. This one is
Negative 2.
negative 2x. This one gets the x. This one gets the
X
2x.
x squared. And this one gets
2x to the third.
2x to the third. Okay, so we're going right down with the place values. 0, negative 2, 1, 2. But then we have our plus 2 over
Yeah.
this one.
X minus 2.
Okay, yeah. Ew. Because that's ugly and we're going to have to fix that.
That is really nice.
Wow.
So this is why maybe your long division on this one might be a little easier for you. Because this is not mathematically beautiful. Okay? We need to fix this. Hey, quiet. We need to fix this part. We can't really have a fraction in the denominator there. So look what happens. Pay attention. In order to get rid of this fraction in the denominator, multiply top and bottom by 2. Okay?
Whoa.
So we get 4 over 2x minus 1, which is really what we kind of started with anyway,
Oh, look at that.
up here. But it's that last little step for the remainder. Then we want to completely clean it up. I'll get you in a second. 2x to the third plus x squared minus 2x. We don't rewrite the 0 because that was just hanging in that spot for us. Plus 4 over 2x minus 1. And that's as mathematically pretty as we can get it.
Is that the answer?
This is the answer right here.
Still
I think it's gross.
I think it's
All right,
supposed to.
Antonia, what was your question?
My question was, if you had another problem like that, would it always be multiplied by 2, or whatever number would make it whole?
Whatever makes it whole, or it makes it an integer. Yeah. Grace?
I think it's gross.
If you truly must, but it's really not the best idea.
It's not good.
All right. So that's it for that.
Yeah, just go.
Hold on.